So I would like to start this presentation by introducing my name, uh, Ahmad Aliu Maidamisa, PhD. I'm an associate professor of operation research in the Department of Statistics and Operation Research, Modibo Adama University, Yola, Nigeria. This work is titled Integer Linear Programming Applied to Nurse Rostering Problem, in which I serve as the main and corresponding author, and Helen Odinya serve as co-author. Now we have to understand that in any hospital operation, there are various wards and nurses that are manned at each wards. And then these nurses works from Mondays to Sundays. And then after a week work, they took off for holidays. Now this becomes an issue when it comes to assigning these nurses to duty posts. In a situation where you have a large pool of nurses with so many wards, then you have to look at it in a sense that it becomes a challenging issue, in the sense that you have to respect the holidays for each nurses, and then the hospital themselves have some restrictions that is desirable. You have to take cognizance of all those before you now make an assignment. So it becomes an assignment problem. You assign a nurse to a shift. Now, this becomes a complex issue when you have so many number of them with so many places of assignment. This problem can be formulated as an optimization problem and then solved using any of these optimization techniques. Now, the objective of this work is to improve on a previous work that was published in international journals of research, scientific research. What we are trying to do is to get a very good schedule, a very good timetable that can respect the assignments, the holidays of these nurses, as well as to meet the goals and aspirations of these hospitals. The material was adopted from the online publication of this scientific research journal. Now, the data was exactly adapted from that work. If you look at this table, the variable stands for the number of nurses, which is our task to be able to determine the feasible and optimal value for these variables. The days are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And for each day, the number of nurses available, for instance, on Monday is 200. Within these 200 is to be assigned to all the wards in the hospitals, bearing in mind that there are some that are due for holidays within that number. And so also on Tuesday also, we have 150 that are on ground, and so on like that. So it becomes an issue where how we will formulate this and into a mathematical programming problem and then solve it to get the feasible values for these variables. Now, as I said earlier, that this node works for 5 consecutive days and then takes 2 days off. So this duty repeating this pattern indefinitely, how can we minimize the number of nurses that staffs this hospital? This is our challenge. Now, this is the methodology that was used in finding the optimal values for these variables. In a compacted form, this problem is formulated into an optimization problem. In this case, is to minimize those variables, subjects to available number of these constraints. The constraints are there. For instance, X1 stands for the number of nurses starting duty on Sunday to Thursday. And then X2 stands for the number of nurses starting duty on Monday to Friday, and so on like that. Now, when this is formulated into an integer linear programming, the problem becomes an LP model like this. Now, if you look at this model, it has 7, 8 constraints, 9 including the non-negativity constraints. As I said earlier, the optimization is minimization, because sometimes it may be maximization. Now, if you look at the number of constraints is so large, and you cannot start it automatically on this. You have to standardize this and then add an artificial subtract surplus first before you now add an artificial variables, and that will increase the number of variables. Now, if you agree with me that when you have any variable that is more than 3, solving it manually will be very difficult, and even not difficult, you may end up very tedious and cumbersome. Sometimes the solution may be erroneous. So, and that is why you have to get a computer program for you to solve this large number of variables. Now, from the results was run a combination of 8 surplus and 7 select variables, making it 15 non-basic variable. And the optimally 300 nurses are optimally required by the hospitals, as against the previous work of 303.33. When you are talking about human, 0.33, we don't have that as a human. So this stands as a remarkable improvement over the previous work. We like to conclude that this work has tremendously improved the paper that was adopted. Thank you.